Hello everyone, I will be doing a Teach 1 on Data Preparation Part 2 for HAP 464. This was narrated by Eric, and this course was taught by Professor Cardenas. As you can see, when we run the hasdisease_dataframe.shape command, we see that there is almost 5 million rows in this data frame. And we want to reduce the amount of rows in total. So we have to decide to remove duplicates for certain columns. And in order to remove duplicates, we have to use the .drop_duplicates function and take a subset of the columns that we want to delete the duplicates in. For this case, we chose to remove person ID, standard concept code, condition start date time, and condition end date time. All of those columns will remove duplicates, will have their duplicates removed. And after running that code above and then running the hasdisease_dataframe.shape function, we see that there's almost a decrease in 1 million. So we want to view the table once more to see if there are any duplicates, and as you can see, there are no longer any duplicates. Hello class, welcome to my tutorial on how to download the Organizing Diseases CSV file. So first, please go to the Open Online Courses website created by Dr. Alemi. This website can be found through navigating the HAP 464 syllabus. So please visit this website and then press All of Us project, and we want to be downloading this one right here, the one that I highlighted, Organizing Conditions CSV file. So you also want to pay attention to where you downloaded this file so you can input it into Jupyter Notebook. Thank you for watching. So we now want to use Pandas library to read the CSV file. So the syntax would be pd.read_CSV and then in parentheses the path of your CSV file. And this will vary from everyone because not everyone will have saved it in a folder. So as you can see, I've saved it in a folder called data, hence why it is ./data/ and then the name of the CSV file. If you just imported it into Jupyter Notebook without putting it into a folder, it would just be ./ and then the name of the CSV file. So moving on to the columns, we see that the column in red has or the circle in red rather has a disease group of a very long number, which is in SNOMED CT, which you can easily look up, which is what I have done for all of you. So the disease group for that number is disorder of the endocrine system, so we can expect to see problems with the glands of the body. And then the standard concept code for the corresponding disorder or disease group is benign neoplasm of adrenal glands. So that is a part of the endocrine system. And moving on to the column or the circle in blue, we see that the disease group is disorder of the musculoskeletal system, and the standard concept code is a closed fracture of the lower leg. So in the has disease grouping data frame, that was the variable that we created when we read the CSV file, and the data type for the standard concept code is int64, which is in the first table, or for the first output that we see, it has an int64 data type. Meanwhile, in our hasdisease_data frame variable, we see that the standard concept code is an object rather than an int64, so we will need to change the data type. So we want to change the data type of standard concept code using the .loc function, which grabs the column that we want to change the data type for. So the syntax is equals and then your data frame name, and then in brackets and then quotation marks the column name, and then closing the brackets dot as type, and then in parentheses quotation marks once again, and then your desired data type, which is in this case int64. And now moving on to our table join, we see that we want to look at the first table, which is has disease data frame, which will be our main table, and has disease grouping data frame, which will be our second table or our right table. In this case, the has disease data frame is a left table, which is also the first table. We want to merge the grouping table with the has disease data frame on the same standard concept code through a left join, which will take all the records from the second table and merge it with the first. Rather, take all the matching records from the second table. And as a result, we get a new disease group column on has disease data frame table, and not everyone will get disease group X and disease group Y. Previously, we created a data frame that was intended for analysis based on person ID, which we named analysis underscore data frame. Please go back and check if you have named it something different so you do not get an error. We now want to join these data frames with analysis data frame being the dominant table, while taking the matching records from the right table or the second table, which is the has disease data frame. And we did it through a left join on matching person ID. Dimensionality reduction is significant to learn in this context because we have seen how much we have reduced a data frame's amount of rows. We went from about 5 million to reducing it to by almost like 1 million. And dimensionality reduction is the process of transforming data from high dimensions. Think of high volume data, which is like kind of raw data, which kind of has no meaning unless you look at a kind of, or take it into a subset. And we want to transform high dimension data to lower dimension data. So think of subsets or smaller data sets. And while we want to minimize the sheer amount of data, it is also significant that the relevancy of the data is maximized so we can know what we are looking for in that data. And the methods of dimensionality reduction is feature selection, which is selecting a subset of data that is most relevant to the task that one is performing. And feature extraction is the act of extracting new features through the process of merging and transforming the original features of data. In order to clean the data, we will keep the rows where condition start date time is less than the earliest antidepressant start date, which indicates that we want to retain rows where condition starts earlier than when the antidepressant use started. So as you can see, in analysis data frame brackets, condition start date time is less than analysis data frame earliest start antidepressant start. So we want to keep rows where the condition start date time is less than the earliest start date time. So condition is we want it where condition starts earlier than antidepressant use. And we also want to drop the index and set it in place. And after running that code, you see that there is an 11.5 million row difference after cleaning the data. Hello everyone, again. Let us look at the result from the analysis data frame table. So as you can see, previously we selected all where the condition start date time is earlier than the earliest antidepressant start date time. So as you can see, for example, in this row, the condition start date time was October 16th, 2016, while the earliest antidepressant start date time was December 18th, 2019. Please check your tables to see if you got the same results, where the condition start date time is earlier than the earliest antidepressant start date time. This is for safe measure, as we want to ensure that the trial numbers exceed 1. In the previous slide, there was only trial numbers with only 1 listed, so we want to run this line of code to see if trial numbers above 1 exist. And as you can see, they do exist. So we want to create a folder named checkpoint that will be the location of where the CSV file will be downloaded. We will then want to use pandas to read the CSV file once again. As I said earlier, the syntax of this will differ from each student depending on the file location or whether or not you have used a folder. So I highly recommend that you do this line of code, the first line of code, by using checkpoint or just any folder name that you want to that is memorable to you. So we did .to_CSV, which saves a CSV file into Jupyter Notebook. So then we have read the CSV file using pandas. And a checkpoint folder should have been created. So if we go to the folder, we will see that the CSV file has created below. So as I have already created the code, this is a snippet of what we will be doing in the code in the next slide. So these two codes for 34 and 35 should be standard concept name and for 34 and standard concept code for row 35. So row 35 should have a data type of int64, and we will now change the names of these columns. We will now change the data types to aid processing. So please pay attention to the integer columns. All of these columns listed below should be integers, listed as integers like int64. So person ID, trial number, dosage days, dosage, other antidepressants, readmission, just all of this should be integers, and the float columns should be age at antidepressant and age at death. And this could just be a problem for me, but I saw that my other antidepressants data type was not int64, it was a float rather, so I had to change it to int64 using the analysis data frame, and then brackets in parentheses the name of the column that is the incorrect data type, and then dot as type, and then parentheses once again in quotations your desired data type. So now we want to create a variable for the date columns, and this is all the column names regarding dates. So earliest antidepressant start, earliest antidepressant end, date of birth, date of death, condition start date time, and condition end date time. And then for column, or we want to create a for loop for in the initialized variable for dates. And by creating the loop, we are able to use pandas to loop through the columns to change the data type to dates and times. With errors being coerced, it is forced to change the data type regardless of the inconsistencies. Finally, we rename the two columns for standard concept name and standard concept code to disease name and disease code, which was seen in the previous slide. And this is to simplify it for future data analysis. And please check the table once again for the correct data frames. Thank you for watching.